Alright guys, here's a homework question that was requested by one of you guys. Use implicit differentiation to find y prime, then evaluate y prime at 4, 3. And this is the equation that they gave us. 2x squared minus y cubed minus 5 equals 0. For this video, we're not going to really go into too much of the concept. We're just going to go straight into how I would really compute this. So the first thing you should know is when you're thinking about implicit differentiation, you just want to keep one thing in your mind, and that's you have to consider just pretend like you're differentiating the entire system as if you're only dealing with x's. Once you differentiate everything as if you're pretending they were all x's, then go back, change the y's back to y's, and then add a term dy dx to the end of said term. So I'm going to explain what I mean right here. So here's our original equation. We have 2x squared minus y cubed minus 5 equals 0. And what I'm going to do now in the next step is I'm going to pretend that all my variables are just x. So I'm going to turn this y into an x. I'm going to keep it highlighted red so we know that that was originally our y term. And now what I'm going to do is I'm going to take the derivative of both sides. I'm going to zoom out just a hair here. Okay, so I'm going to take the derivative of both sides. So now this is standard procedure, right? If I have the derivative of something like this, I just distribute that derivative or that d dx across, right? That's using the sum rule that we went over a while ago. And then what I go ahead, I differentiate each one of these terms. Now these two last terms, d dx of 0 and d dx of minus 5 is super easy. Why? Because they're both constants. So therefore, their slope of a constant function is just 0, so their derivative is 0. These two, though, that we have to actually do some power rule kind of adjustment to them. So if we use the power rule and we differentiate all these terms, you get 4x minus 3x squared plus 0, that's this constant right here, equaling 0, which is this constant over here. Now, after you simplify, what we're going to do is, remember, this was our pretend equation. This was when we turned y into x. What I'm going to do is I'm going to transform it back into the actual equation. So I'm going to take this x and I'm going to turn it back into y. But because I differentiated, I'm also going to add this dy dx to any term that had a y in it. So it's going to look like this. I change my x back to y. And because this guy was differentiated in terms of, but his variable was y, I'm going to multiply this whole guy by dy dx. So anytime you change a variable from x back to y, you got to multiply it by dy dx. Okay, so then remember what the question is asking us. They want us to solve for dy dx. Okay, that's easy now. We know how to do that. Just some simple algebra, right? I have to rearrange my equation, so I have dy dx all alone. So I'm solving for dy dx. I subtract 4x from both sides, and then I divide by minus 3y squared. So we've done it. We've successfully figured out what y prime is equal to. Y prime is equal to 4x divided by 3y squared. Notice how my two negatives got canceled out when I divided. Now, the other part of the question is they want us to evaluate this function, y prime, for when x equals 4 and y equals 3. So guess what the last step is? We literally just plug in 4 for x and 3 for y. So what do we get? There we go. 16 over 27. Not bad, right? Okay, so what if you're taking a test and you completely forget how to do implicit differentiation? Well, for this question, if you have this question on a test, what you could have done actually was you could just solve for y, right? So you could rearrange this whole thing so that you have only y on one side. And once you solve for y, you can just differentiate this guy like normal. So you could just take the derivative. And for this one, you have to use the chain rule. I'm not going to go too much into the chain rule in this video because this is just if you get stuck on an exam. I'm just showing you that you could solve for y and then take the derivative of both sides. So this is the result after you take the chain rule, after you do the chain rule. And then if you take the derivative, you have dy dx on the left side, and it all simplifies out to this. All right, so this equation and this equation are kind of the same. So the last thing we got to do is just plug in 4. Once you plug in 4 for x, you'll get the same answer, which is 16 divided by 27.